Hello students, welcome to my channel. Today we will do the exercise 3.1 and I hope all of you understood my previous video in which I explained the concept related to exercise 3.1. So let us start exercise 3.1, and if any issues you found in the concept explanation video, then please inbox me. Now let us start the exercise 3.1. Exercise 3.1 number 1. Using the method of mathematical induction, show that 1 plus 3 plus 5, this is what given in the question as I explained in the previous video. So first n equals to 1, then n equals to k, then n equals to k plus 1. This one we will prove, and this one we will assume. Remember that much only. This we have to prove left hand side, right hand side. Equal, sometimes maybe greater, but this one we will assume. So first part, solution, let Sn equals to 1 plus 3 plus 5 plus 2n minus 1 equals to n square. So now for n equals to 1, first part. We have to start from n equals to 1. LHS equals to 1 is 1 only. First term 1, 1. We cannot do anything. Nothing to do here. Right hand side n square. N square means 1 square is also 1. That means LHS, RHS equal. Therefore, Sn is true for n equals to 1. That is finished. First part is finished. Now second part, what we have to write? Let us assume Sk. What is Sk now? 1 plus 3 plus 5 plus 2k minus 1 is equal to k square. Be true for n equals to k. In place of n we have put k, and that is what? True, just we have assumed. Third part, to prove that s k plus 1. Now we will write this term plus k plus 1 term. So same thing, this one we will write first 1 plus 3 plus 5 plus 2k minus 1 plus its next term will be 2 k plus 1 minus 1. This way 2 is in each place, k will be k plus 1, minus 1 is minus 1. I hope you understand. This is example I already explained in previous video. 1 to 5 and 1 to 6. How can we write? 1 to 5, then 1 to 5, then 5 plus 1. No? 5 is as it is 5. Next term will be 5 plus 1. This is S5 and this is S6. I hope you understand. 6 means what? 5 plus 1. S5 plus 1. S5 till 5. So S6 will be 5, then one more term. 5 plus 1. I hope you understand. SK plus 1. This one I explained in previous video. Please go through the video, then you will understand properly again. Repeat the video. So is true for s equals to n equals to k plus 1. For n, in place of n, if we put k plus 1, then right hand side, left hand side, right hand side equal. Right hand side not written. What is right hand side? K plus 1 whole square. N means k plus 1. In place of n, k plus 1 is written. So n is k plus 1. N square, n means k plus 1. Here n is k, so k square. Now this is left hand side and this is right hand side. We will write left hand side now. 1 plus 3 plus 5, then 2k minus 1, 2k minus 1 plus 2k plus 1 minus 1. This is left hand side. So here to here, 1 to 2k minus 1 equals to how much? K square. So in place of here to here, this place, we can write k square plus 2k plus 2 minus 2. I hope you understand. 2 is multiplied with k plus 1, with not minus 1, sorry. Minus 1. 2 into k, 2k, 2 into 1, 2, then minus 1 separately. So k square plus 2k plus 1. 2 minus 1 is 1. This one more time we can write. If you cannot understand, if you cannot do proper directly, then we can make it a square plus 2ab plus b square, which is a plus b whole square, which is right hand side, k plus 1 whole square. By doing calculation in left hand side, we have got right hand side, correct? So therefore, this one you have to write as n is true for n equals to k plus 1. So as n is true for all n belongs to n. We have to prove 1, k and k plus 1. K plus 1 calculation must be done. Number 2. Number 2. So let us start directly. Let Sn equals to 2 plus 4 plus 6 plus 2n equals to n into n plus 1. So for n equals to 1, LHS, first term is 2. So directly 2. RHS, in place of n, what we will put? 1. 1 into 1 plus 1 equals to 2. 1 plus 1 is 2. 2 into 1 is 2. LH is 2. RH is 2. Therefore, Sn is true for n equals to 1. First part is finished. First part is finished. Now second part. Second part is k. Let us assume Sk. What is Sk? 2 plus 4 plus 6 plus plus 2n now to k equals to n into n plus 1. So k into k plus 1 be true for n equals to k. In place of n, if we put k, that will be true. That is what we assume. Now third part. Second part is finished. Third part is for k plus 1. To prove as k plus 1. What is k plus 1? 2 plus 4 plus 6 plus 2k plus 2 k plus 1. K plus 1. In place of k, what? K plus 1. Or in place of n, k plus 1. K plus 1. Again bracket. In place of n, we will write k plus 1. Again plus 1 is originally there is. Plus 1 originally there is. So this is what we have to prove, as k plus 1 is true for n equals to k plus 1. Now we will do left hand side. Left hand side. What is left hand side? 2 plus 4 plus 6, 2k plus 2, k plus 1. Now this must 2 plus 4 plus 6 plus 2k equals to k into k plus 1. So till 2k we can write k plus, in place of this part we can write k into k plus 1 plus 2 into k plus 1 as it is. This one we will do here now. K into k square plus k square plus k plus 2k plus 1, k square plus 3k plus 1, I think it is. Somewhere there is mistake. 2 into k, 2k, 2 into 2, 2. Yes, this is what mistake. Calculation mistake. Okay. 2, 2. K square, k plus 2k, 3k plus 2. This one we can do middle term factorization, which you know, all of you. All of you know about this middle term factorization. 2, 2, 1 is 2 and 2 plus 1 is 3. K square plus 2k plus 1k plus 2. K can be taken from this 2, k plus 2. Here 1 can be taken common, k plus 2. So k plus 2 taken common from both. What is k plus 2? K plus 2 common. K plus 1. K plus 1 is left. Now we will see what is there in right hand side. This is right hand side. So in first right hand side there is k plus 1. Let us write k plus 1 first. In between there is multiplication sign, so we can write k plus 1 here. No problem for it. Next there is k plus 1 plus 1. But there is k plus 2. So we can make it as there is in right hand side. So right hand side. So left hand side is equal to right hand side. Therefore as k plus 1 is true for n equals to k plus 1. Again therefore as n is true for n equals to n belongs to natural number. That is what we can write. Next, number 3. 3. Directly let us write first directly. We don't have to think anything. Let Sn equals to 1 square plus 2 square plus 3 square plus n square equals to n into n plus 1 into 2n plus 1 by 6. So whatever question is there, first duty is to put let Sn equals to whatever term is given, whatever. So in exercise 3.1, or each and every sum is just like this. So I will not repeat again and again. So next, first duty is to write for n equals to 1. So LHS equals to 1 square is 1. First term is 1 square 1. RHS, let us do the calculation. In place of 1, 1 and 1. So 1 into 1 plus 1 into 2 into 1 plus 1 by 6. 1 into 1 plus 1 is 2. 2 and the 2, 2 plus 1, 3. 6. 2, 3 is 6. 6 cancel 1. So RSS equal, therefore Sn is true for n equals to 1. First duty is finished. Second duty, let us assume Sk. There will be no space. So let me write here 1 square plus 2 square plus 3 square plus n square is equal to n into n plus 1 into 2n plus 1. Sorry, we have to use k because Sk now. K square is equal to k into k plus 1 into 2k plus 1 by 6. Just in place of n, we have to put k. This is left hand side, this is right hand side. Okay, but this one we don't have to prove. We can write be true. Let Sk be true for n equals to k. This is what always we have to write. Now to prove that what 1 square plus 2 square plus 3 square plus dot 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 plus k square, next k plus 1 whole square, k square, next time will be k plus 1 whole square, 5 square, next will be 5 plus 1 whole square, or 5 square, next will be 6 square. I hope you understand. Equals to prove that s k plus 1 I have not written, s k plus 1, k plus 1 in place of n k plus 1, remember that. So n k plus 1, again bracket, there is n means k plus 1, plus 1 is there, one more there is, again 2n, 2 k plus 1 plus 1 by 6. I hope you understand. 2, as it is 2 written, in place of n k plus 1 is written, then plus 1 as it is. Now we will do the calculation for left hand side. Here to here, this is left hand side. Let us write left hand side. 1 square plus 2 square plus 3 square plus n square plus k square plus k plus 1 whole square, left hand side. So here to here we can write something. Here to here, this one we can write in place of that, k into k plus 1 into 2k plus 1 by 6 plus k plus 1 whole square. Now we will take LCM. k plus 1 into 2k plus 1 plus 6k plus 1 whole square. I hope you understand. Just LCM is taken 6 into this. Now we will take common. Here k plus 1, here also k plus 1. 1 k plus 1 we can take common. So k plus 1 taken common. What is left? K into 2k plus 1. K into 2k plus 1. Let us multiply k into 2k square, k into 1 k. Here k plus 1 whole square was there. K plus 1 is already taken common. So one more k plus 1 is left. 6 into k, 6k, 6 into 1, 6. Here it is 6, k plus 1 into 2k square plus 6k plus 1k, 7k plus 6. Now we will go to middle term factorization. Middle term factorization. And all of you know middle term factorization. Let us go to next page. K plus 1 into 2k square plus 7k, 2k square plus 7k plus 6. This one we will do middle term factorization. Middle term factorization all of you know. Still I will repeat. This is the technique of writing middle term. 2 into 6 is 12 and 4 3s are 12 and 4 plus 3 is 7. That is middle term factorization. Shortly I have explained. If you forget, you can see that 6. K plus 1, 2k square, 4k plus 3k plus 6. Again k plus 1, 2k can be taken from first two terms. 2k square plus 4k, we can take 2k common. Then from these two terms, we can take 3 common, k plus 2. 6, k plus 1, k plus 2, 2k plus 3, k plus 2, k plus 2, k plus 2 common. What is left? 2k plus 3. Now we will see what is in right hand side. This is right hand side. K plus 1, k plus 2, 2k plus 3. Let us write here k plus 1, then k plus 1 plus 1, then 2, then 2, k plus 1 plus 1, I hope. Yes. This is what there is right hand side. This is right hand side. Our aim is to get this term. As it is exactly this term, we have to get. So let us see what do we get. First k plus 1, in right hand side also there is k plus 1. So I have written. Next k plus 1 plus 1. So this one we can write k plus 1 plus 1. K plus 1 plus 1. Next 2k, 2 into k plus 1 plus 1. 2k plus 3. Let us write like this first. 2k plus 2 plus 1. Same thing I think. 2k, I have written 2k as it is. Then 3, I have written 2 plus 1 so that we can get that. 6, k plus 1, k plus 1 plus 1, 2 can be taken common from first two term. Then this is equals to right hand side. Therefore, that last part you can write yourself. Next, number 4. Directly as let I have not written. Let Sn is equal to 1 square plus 3 square plus 5 square plus 2n minus 1 whole square equals to n into 2n minus 1, 2n plus 1 by 3. This is for Sn. Now we will go directly for n equals to 1. LHS 1 square equals to 1. First term. Now we will go to right hand side. Right hand side. N equals to 1. So wherever there is n, we will put 1. One into 2 into 1 is 1 minus 1. 2 into 1 is 2. 2 minus 1 is 1. 2 into 1 is 2. 2 plus 1 is 3. 3 cancel 1. So LHS is 1. RHS is 1. RH is done. Calculation is done. There is no complication. You can understand very easily. So therefore, Sn is true for n equals to 1. Now let us assume Sk. What is Sk now? I will write this side. You will write please like this way. Because of the lack of space, I am writing this side. That 1 square plus 2 square plus 3 square plus 1 plus 3 plus 5 there was no. Okay, 2n minus 1 square. Now what you have to write? K. Sk. So 2k minus 1 whole square equals to k into 2k minus 1, 2k plus 1 by 3. Just putting the value of n, k. Be true for n equals to k. It will be true for n equals to k. That is assumed. Now to prove that as k plus 1, what is k plus 1? Let us see now. 1 square plus 3 square plus 5 square plus 2k minus 1 whole square. Till this must return. K is till this must k. Next k plus 1. Just in place of k, we will write k plus 1. Nothing else. K, just written k plus 1 equals to, right hand side we are going to write now. Equals to, in place of n we have to write k plus 1. N means k plus 1. K plus 1 I have written only for n. Next I have to write 2 in place of n, k plus 1. K plus 1 then minus 1. Next 2n plus 1. 2 k plus 1 plus 1 by 3. This is right hand side. This is right hand side. This is left hand side. We will do the calculation from left hand side so that we get right hand side. left hand side, let us write 1 square plus 3 square plus 5 square, 2k minus 1 whole square, 2k plus 1 minus 1 whole square. This is left hand side I have written. Here to here we can put the value. Here to here the value is this one. K into 2k minus 1, 2k plus 1 by 3. This one. Plus this one we can write 2 square 4 you can write directly. 2k plus 1 whole square. Okay. This one 2k plus 2 minus 1 whole square. Let us write 3k, 2k minus 1, 2k plus 1 plus this one write shortly 2k plus 1 whole square. 2 minus 1 is 1. Now LCM 3k, 2k minus 1, 2k plus 1 plus 3 into 2k plus 1 whole square. Let us go to next page. Let us go to next page. Okay. Okay, let us see from here only. K into 2k minus 1, 2k plus 1. K into 2k minus 1 into 2k plus 1 plus 3 into 2k plus 1. 3 into 2k plus 1 whole square by 3. I hope there is 3, I think. Yes, 3. Now K 2k minus 1, 2k plus 1 plus 3, 2k plus 1 into 2k plus 1. 2k plus 1 whole square I have written twice so that we can take common. Now common 2k plus 1. What is left here? We will multiply. K into 2k, 2k square minus k, k into 1 k plus 3 into 2k, 6k plus 3. 2k plus 1, 2k square plus 5k plus 3 by 2. 2k square plus 5k plus 3. Okay. Now middle term factorization again. 2k plus 1. This one 2k square plus k plus 3. Here 3 plus 2. 3 plus 2 is 5. 3 to the 6 because 2 3 is 6. 2k plus 1, 2k plus 3k plus 2k plus 3 by 3. 2k plus 1. Here we can take common k. K then 2k square, okay. 2k plus 3. Here we can take one common 2k plus 3 by 3. Now 2k plus 1, 2k plus 3, only k plus 1. Only k plus 1 is k plus 1. K plus 1 by 3. Let us see right hand side what is there. First k is there. Sorry, here. First k plus 1 is there. So we will write first k plus 1 then minus plus. First k plus 1. Let us write k plus 1 first. K plus 1 first because in left hand side, in right hand side there is k plus 1. Next there is this is right hand side. 2 into k plus 1 minus 1. 2 into k plus 1. Okay, wait. If I write shortly, you may not understand. This one, 2 into k plus 2 minus 1. Same meaning only. Look here. 2k plus 1 is there. So 2 minus 1 is 1. Why it is written minus 1? Because here there is minus 1. This one we will write now. 2k plus 2 plus 1. I hope you understand. We are following right hand side. Now k plus 1. This one we will modify. 2 into k plus 1 minus 1. This one also 2 into k plus 1 plus 1 by 3 equals to right hand side. Now number 5. Number 5. Okay. First, directly solution. Let Sn is equal to 1 cube plus 2 cube plus 3 cube plus n cube is equal to n into n plus 1 as a whole square by 2. Directly. For nothing there is to worry. You don't have to worry what is to write. Directly for n is equal to 1 LHS. First term is 1 cube, that is 1 only. 1 cube, that is 1. Now let us see what is right hand side. What do we get right hand side? 1 into 1 plus 1. 1 into 1 plus 1 is 2. 1 into 2 by 2 whole square, it is 1 only. So left hand side is 1, the RH is also 1. Therefore Sn is true for n equals to 1. Now let us assume Sk 1 cube, 2 cube, 3 cube plus n cube, sorry, not n cube, k cube, because k, then k into k plus 1 as a whole square. I hope you understand. N into n plus 1. Now k into k plus 1. Next time what you learn? In place of n, k plus 1. In place of n, k plus 1. Now we have written in place of n, k. Just only k. Be true for n equals to k. Second part is finished. Now to prove s k plus 1. S k plus 1. So what? 1 cube plus 2 cube plus 3 cube plus k cube plus k plus 1 whole cube. K till k cube. Okay. Next k plus 1. So next term. I hope you understand that. Already I explained many times. So now n means k plus 1. K S n. N means k plus 1. So first n is k plus 1. Second n also k plus 1 plus 1. Okay. And k plus 1. Again second n also k plus 1. With n there is one more plus 1. So this is plus 1. So this is right hand side. This is left hand side. Let us write left hand side first. 1 cube plus 2 cube plus 3 cube plus k cube plus k plus 1 whole cube. So here to here how much? 1 cube to k cube equals to this. K into k plus 1 by 2 whole square. Value of this plus k plus 1 whole cube. Now k into k plus 1 square square. This is square for numerator. K square is k square. K plus 1 square is k plus 1 whole square. 2 square is 4 plus k plus 1 whole square. Okay, now we will take the LCM. I hope till this much you have understood. Nothing is done. Here there is no complication. Don't worry about the sum. Just to put the value and do the calculation. If you are weak in calculation, then there will be mistakes. Okay, k square into k plus 1 whole square plus 4 into k plus 1 whole cube. Okay. Now right hand side, see what is there. We have to, when you are doing left hand side, then you have to follow right hand side. Actually right hand side, what is there? K plus 1 whole square. K plus 1 whole square is there. K plus 2 whole square is there. 2 square is 4 is there. So just imagine, means just you can calculate in your mind that actually we are supposed to get here also k plus 1 whole square. So k plus 1 whole square, k plus 1 whole square, we can take common. We can take common. K plus 1 whole square, let us take common. Okay, because there is k plus 1. Now after taking k plus 1 whole square common, here only k square is left. K square is left. Here k 4 into k plus 1. Only 4 into k plus 1. I hope you understand. What is left? K plus 1 whole square. K square, okay, k square plus 4k plus 4, k square plus 4k plus 4 by 4. Look here, k plus 1 whole square. This one we can write this way, k square plus 2 dot k dot 2 square by 4 k plus 1 whole square. This one k plus 2 whole square we can write a square plus 2ab plus b square. This is similar. What is there in right hand side? K plus 1 whole square. That means k plus 2 whole square. We can write now k plus 1 whole square, k plus 1 whole square to make it similar to right hand side. So now k plus 1 by 2 whole square, so that we get as it is as right hand side. Right hand side, k plus 1 by 2 whole square. So this is finished. The below part you will write yourself, please. This is not the ending of the sum. You will write, therefore Sn is true for Sn is true for all n belongs to n. It is there in the book, you can follow that. Number 6, let Sn equals to 2 plus 2 square plus 2 cube plus dot 2 to the power n, 2 into 2 to the power n minus 1. So directly for n equals to 1, LHS equals to 2, first term is 2. Now we will go to right hand side, 2 into 2 to the power 1 minus 1, because n equals to 1. 2 into 2 square, 2 minus 1 into 1 is 2. LHS 2, RHS 2. Therefore Sn is true for n equals to 1. Now let us assume Sk 2 plus 2 square plus 2 cube plus 2 to the power n equals to, 2 to the power k, not n, because Sk now, 2 to the power k is equal to 2 into 2 to the power k minus 1. Be true for n equal to k. Now to prove to prove that as k plus 1, what is as k plus 1? 2 plus 2 square plus 2 cube plus 2 to the power k plus 2 to the power k plus 1, just k, then k plus 1. 2 to the power, not k now, what is k plus 1 minus 1 is true for n equals to k plus 1. N equals to k plus 1. Now we have to do the calculation for left hand side and right hand side. We will do the calculation for left hand side. Let us write left hand side. 2 plus 2 square plus 2 cube plus 2 to the power k plus 2 to the power k plus 1. So this one what can be written? 2 to 2k, well, this is the value. 2 to the power k minus 1. You have understood this one, I think, because everywhere, each and every sum I have been applying this method, which is easy for you. 10 plus 2 to the power k plus 1. Okay. 2 into 2 to the power k. 2 into 2 to the power k, 2 into 1 is 2 plus 2 to the power k plus 1. Now 2 to the power k plus 1 we can write directly. I hope you understand this one. 2 to the power 3, 2 to the power 4, we can add 2 to the power 3 plus 4. 2 to the power 1 into 2 to the power k. So 2 to the power 1 plus k or k plus 1, same thing. Then this plus 2 to the power k plus 1, let us write together, then minus 2. 2 to the power k plus 1 plus 2 to the power k plus 1. Let me show you one example. X square plus x square. Can you write 2x square? Or x square, x to the power 2 plus n plus x to the power 2 plus n. We can write 2x to the power 2 plus n. I hope you understand. X square plus x square, 2x square. X to the power something plus x square, x to the power something. 2x to the power something. 2 to the power something plus 2 to the power something. 2 to the power something means same thing. 2 to the power k plus 1, 2 to the power k plus 1. 2 to the power k plus 1. I hope you have no problem to understand this. Again I will show you. 2 to the power 5 into 2, sorry, plus 2 to the power 5. So 2 into 2 to the power 5, 2 times 2 to the power 5, how many times? 2 times. 2 times 2 to the power k plus 1. So that is what I have written here. Now we will take 2 common. Right hand side, this one is right hand side. We have to follow right hand side. 2 is taken common. What is there inside the bracket? 2 into 2 to the power 2 into 1 is 2 equals to right hand side. Last part of the sentence you will write yourself. Number 7. Let Sn equals to 1 factorial 1, 2 factorial 2 plus 3 factorial 3 and factorial n equals to factorial n plus 1 minus 1. Okay, now directly for n equals to 1. Left hand side 1 factorial 1 is 1 only. Right hand side factorial 1 plus 1 minus 1. 1 plus 1 is 2 minus 1. Factorial 2 is 2 into 1. 2 into 1 is 2. 2 minus 1 is 1. So left hand side, right hand side equal. Therefore, Sn is true for n equals to 1. Let us assume Sk 1 factorial 1, 2 factorial 2, 3 factorial 3 plus k factorial k equals to k plus 1 minus 1 be true for n equals to k. Now to prove that, to prove that, what to prove, as k plus 1, 1 factorial 1, 2 factorial 2, k factorial k plus k plus 1 factorial k plus 1. K will be k plus 1, k will be k plus 1. Nothing is done extra. Nothing is new. Equals to k plus 1 minus 1. I hope you understand. N means now k plus 1. So in place of n, just I have put k plus 1. Under the factorial there is plus 1. So I have written plus 1. And separately minus 1, I have written separately minus 1. And this is right hand side. Now we will start from left hand side. Okay, let us write first. 1 factorial 1, 2 factorial 2, 3 factorial 3 plus k factorial k plus k plus 1 factorial k plus 1. Now here to here, this is the value. Okay. Now we have to follow right hand side. What is there in right hand side? Actually what we are supposed to get, under the factorial we have to get k plus 2. So here also we will try to get k plus 2 under factorial. Okay. So okay, we can do one thing. From this term and from this term, we can take factorial k plus 1 common. Here 1 will be left. Here k plus 1 will be left, separately minus 1. Minus 1 we will keep as it is till last minus 1 only, because there is minus 1 separately. Now factorial k plus 1 into k plus 2 minus 1. Actually what is there in right hand side? Actually there is, let me write inside the box, factorial k plus 2 then minus 1. Minus 1 we have with us, but factorial k plus 2 we don't have with us. Now I will show you some example. Already I showed this example in previous video. Factorial 5 means 5, 4, 3, 2, 1. Or we can write factorial 5 is equal to 5 into factorial 4. I hope you understand this one. Already I explained in previous video. Already I explained in previous video. 5 into factorial 4 means factorial 5. Now, in place of factorial k plus 1, can we write k plus 1? Okay, let me explain this one first. Factorial k plus 1, look here. Factorial k plus 1. 5 means factorial 4 plus 1. 5 means 4 plus 1. So I have kept as it is. Or let me write 4 plus 1 factorial 4. Same thing I have been writing again and again. 5, 4 plus 1, 5 is 5. Now next 5, 4 plus 1, factorial 4, as it is I have written. Now you may understand what I want to explain. Factorial 4. Only 4 plus 1. K plus 2. K plus 1. I will show you again. K plus 2 and k plus 1. Factorial is there in this one, what is called, let me write this one now. 3 factorial 4 factorial k plus 1 means smaller, k plus 2 means bigger, k plus 1 smaller, k plus 2 bigger, 5 is bigger, 4 is smaller. Look here, 5 is bigger, 4 is smaller. In smaller, factorial is there. In bigger, no factorial is there, but result is bigger factorial. Look here, bigger into smaller factorial equals to bigger factorial. Let me show you this way. 5 into 4 factorial equals to 5 factorial. I hope you understand. 5 into 4 factorial is equal to 5 factorial. Bigger into smaller factorial is equal to bigger factorial. This is bigger. K plus 2 is bigger. Bigger, this is smaller. Factorial is there in smaller. I hope you understand. Bigger into smaller factorial. Bigger into smaller factorial. Bigger into smaller factorial is equal to bigger factorial. So bigger factorial we can write directly. This one you will understand. Please repeat the video twice, thrice. Then you will understand. You will take some example yourself. Then you will understand this equals to right hand side. Sorry, k plus 1 we can write this way minus 1. Right hand side we have got equals to right hand side. Number 8. Let Sn is equal to 2 into 6 into 10 into 14 4n minus 2 equals to factorial 2n by factorial n. This is what given in the question. So first, for n equals to 1, LH is equal to 2, directly 2. Now RHS factorial 2 into 1, n means 1, factorial 1, 2 into 1 is 2, 2 only, 2 by 1 is 2, LHS 2, RHS 2, therefore Sn is true for n equals to 1. Let us assume S K 2, 6, 10, 14, 4k minus 2 is equal to factorial 2k by k be true for n equals to k. To prove that as k plus 1, what is k plus 1? We will write now 2, 6, 10, 14, 4k minus 2 till k. Next will be into 4k plus 1 minus 2. K will be k plus 1 equals to factorial twice n, factorial 2k plus 1 by factorial k plus 1 is true for n equals to k plus 1. Okay, this sum is easy. Now we will do left hand side. Let us write 2, 6, 10, 14, 4k minus 2, 4k plus 1 minus 2. This is left hand side. Here to here we can write here to here we can write factorial 2k by factorial k. Factorial 2k by factorial k into this one 4k plus 4 minus 2. Multiply 4 into k, 4k, 4 into 1, 4 minus 2. Factorial 2k into 4k plus 2. Factorial k. Factorial 2k 2, not 4. We can take 2 common. 2k plus 1 by factorial k. What is there in right hand side? This is what in right hand side. Okay. Now we will see how can we make a right hand side. Inside the bracket k plus 1 is there. That one we will see later on. Now we will go to we will multiply by k plus 1 numerator and denominator. Why I am multiplying, I will explain now. This one bracket is not required, this big bracket. We can write directly into factorial 2k, 2 into 2k plus 1. Okay. Now, this k plus 1, why do you multiply in numerator and denominator? Look here. Here there is k plus 1. In the previous video, previous page, I have explained this one. If we don't get here k plus 1, then only from this factorial k, we cannot get k plus 1. Now we can directly write factorial k plus 1. It is like this. K plus 1 is bigger. Factorial 4. 5 into factorial 4 will be factorial 5. This one just in previous page I explained. 5 into factorial 4 will be factorial 5. So bigger into smaller factorial will be bigger factorial. Otherwise, if we don't have this k plus 1 with factorial k, then we will never get factorial k plus 1. That is why k plus 1 is multiplied in denominator. If we multiply anything in denominator, we have to multiply in numerator also, that you know already. So this 2, let us multiply with this k. 2k plus 2. 2 is multiplied with this. Then 2k plus 1. Then factorial 2k. 2k plus 1. 2 into k, 2k plus 2. 2k plus 2. 2k plus 1 plus 2k. It is like this. 5, 4, factorial 3. I hope you understand. 2k plus 2 bigger, 2k plus 1 smaller. Factorial 2k is the smallest, biggest and smallest, biggest and smallest. So this one can be written factorial 5, 5, 4, factorial 3. So this one means 5, 4, 3, 2, 1. 5, 4, factorial 3 means 3, 2, 1. So 5, 2, 1 means factorial 5. So 2k plus 2, 2k plus 1, factorial 2k. What can be written? Factorial 2k plus 2. This is 5. This is 4. This is 3. Factorial is there in 3. 5 into 4 into factorial 3 will be factorial 5. I hope you understand. This one, if you have understood this one you will surely understand. And factorial k plus 1. This one more line we will write factorial 2k plus, 2 into k plus 1. 2 is just taken common so that you can make it similar to right hand side. 2 is taken common here. 2 into k plus 1. 2 into k plus 1. I hope you understand. Equals to right hand side. Number 9. Let Sn 2Sn equal to 2n plus 7 smaller than n plus 3 whole square. So directly for n equals to 1, LHS 2 into 1 plus 7. Let us do the calculation. 2 1 2, 2 plus 7, 9. LHS. Right hand side n plus 3 whole square. Sorry, not n. Directly 1 you can write. 1 plus 3 whole square. 1 plus 3 whole square 4. 4 square is 16. LHS is smaller than RHS. LHS smaller than RHS. Therefore, Sn is true for n equals to 1. We assume Sk 2k plus 7 k plus 3 whole square be true for n equals to k. Very simple. Previous sums there was equal sign in between left hand side and right hand side. Now there is smaller than sign. So let it be like this. We will do continue as what we do for equal sign. Okay. Now to prove that s k plus 1, let us write this one only now. So same thing, 2 k plus 1 plus 7, sorry, 2 k plus 7 2 k plus 1 plus 7 smaller than, in place of n now k plus 1, because s k plus 1. In previous sums equal sign was there, so we have done till k, then k plus 1, but here is smaller than sign, so we cannot use that. Just we will put the value of n as k plus 1. Here n plus 3 whole square, so k plus 1 plus 3 whole square in place of n k plus 1. I hope you understand. Is true for n equals to k plus 1. Now LHS we will do. Okay, we will do LHS very easy. The sum is very easy. 2 into k plus 1 plus 7. 2 into k plus 1 plus 7. 2k plus 2 plus 7. 2k plus 9. Now let us do right hand side. K plus 1 plus 3 whole square. K plus 4 whole square. K square 8k 16. A plus b whole square formula directly I have applied. Now by looking this, or we can do this one. 2k plus 9 plus k square plus 6k plus 7. 2k plus 6k, 8k, 9 plus 7, 16, k square is k square. Why 2k plus 9 I have written here directly? By looking this LHS, we have to show LHS is smaller than RHS. 2k plus 9 plus something in right hand side. Here only 2k plus 9. Okay, let me explain again. 2k plus 9, 2k plus 9 plus something, whatever it is, something. With 2k plus 9 something is added, that means this is bigger, this will be small. So 2k plus 9 plus something. So by looking these two terms, we understand that LHS is smaller than RHS. Therefore SK plus 1 is true for n equals to k plus 1. Therefore Sn is true for n belongs to natural number. Number 10. Let s n equals to 2 to the power n greater than n. So direct for n equals to 1. For n equals to 1. This is left hand side, this is right hand side. Left hand side. 2 to the power 1. N equals to 1. So 2. R H S N. And I will add 1 only. 1. LHS is 2. RHS is 1. LHS is greater than RHS. LHS is greater than RHS. Therefore, SN is true for n equals to 1. Now let us assume S k 2 to the power k. Here only you can write. Here only we can write 2 to the power k is greater than k. This one we can write like this only. Be true for n equals to k. So this sum will be little different, not like other sums, because in other sums we have done left hand side and right hand side. Here greater than sign is there, so we will do something different, little different here. So same, the steps are same to prove that s k plus 1 2 to the power k plus 1 is greater than k plus 1 is true for n equals to k plus 1. Okay. Now since we will not do LHS RHS because no equal sign. Since this one we have, because we assume already, so 2 to the power k is greater than k. Now we will multiply both side by 2. Both side by 2. Why? Why we have multiplied both side by 2? Because here we have what we have to prove? We have to prove 2 to the power k plus 1. 2 to the power k is there. If there is one more, then only we will get 2 to the power k plus 1. I hope you understand. Now k plus 1, but here is 2k. So which we can write k plus k. Now this one I will write directly k plus 1. This is k plus 1. This k we can write 1. Already I explained in previous video how it is. Look here. Suppose k is 3. Suppose k is 3. Let us write this line. 2 to the power 3 plus 1. K is 3. I have told you already. K is 3. Greater than 3 plus 3. 2 to the power 3 plus 1 is 4. 3 plus 3. 2 to the power 4 is 16. 3 plus 3 is 6. 16 is greater than 3 plus 3. 16 is also greater than 3 plus 1. We can write this. So k plus k, we can add k plus 1. Meaning is same. 2 to the power 4 is greater than 3 plus 3 and 2 to the power 4 is also greater than 3 plus 1. Why do we write here 1? Because in right hand side there is 1. That is why we have written k plus 1, because meaning is same. I have here shown what is the meaning. So hence proved. 11. Let Sn is equal to factorial n greater than 2 to the power n, and condition is given n is greater than 4. This type of sum is there in example also. Look here. For n equals to 1, generally what we have to do? We have to go for n equals to 1 only first. Now left hand side, factorial 1 is equal to 1. Right hand side, 2 to the power 1 is equal to 2. Left hand side we have got 1, right hand side we have got 2. That means LHS. Are we getting LHS is greater than RHS? No. Why? Why we did not get correctly? Why we have not got LHS is greater than RHS? Because we have taken n equals to 1. But there is given condition n is greater than 4. So, what we have to take? N equals to 5. For, I hope you understand now. For n equals to 1, generally we would do all the sums. But here condition is given that n is greater than 4. So, if we take n equals to 1, 2, 3, 4. Till 4, if we do the calculation, we will not get LHS is greater than RHS. Now, let us see n equals to 5 if we put. Let us see that whether we get left hand side greater than RHS or not. So, left hand side now. Factorial 5. Factorial 5 means 5 into 4 into 3 into 2 into 1. 5 for the 20, 3 the 60 to 120. Right hand side. Right hand side. 2 to the power 5. 2 to the power 5 is 32. So left hand side is greater than right hand side. Left hand side is greater than right hand side for n equals to 5. Therefore, okay, here we can add LHS is greater than RHS. Therefore, SN is true for n equals to 5, not 1. Previous all the sums we have been doing for 1 because condition was not given. But here condition is given n equals to 5. Now we will go to K. Let us assume K 2 to the power K be true for n equals to K. To prove that as K plus 1 now, factorial K plus 1 is greater than 2 to the power K plus 1. This is what we have to prove. So there are two processes to do this sum. So I will show you both the processes. First, let us do from LHS. From LHS. What is LHS? Factorial K plus 1. Factorial K plus 1. This factorial K plus 1 we can write K plus 1 into factorial K. Why it is done like this I will tell you later on, but how it is done let me show you. 5 plus 1, let me write like this 5 plus 1. Next will be, this is 6 actually, next will be 5. Factorial 5 plus 1, factorial 6 into 5 or 5 plus factorial 5 plus 1 into 5. Okay, can you write 5 plus 1 into factorial 5 or 6 into factorial 5? These all are same meaning. I will show you. 6 into 5. 6 into factorial 5, same meaning. Factorial 6 into 5 for like this. Wait, I am not saying that. 6 into factorial 5 or factorial 6, same meaning. Okay, so this one means 5 plus 1. This one means K plus 1. K plus 1 factorial K. So we can write factorial K. 6 into factorial 5. So, sorry, yes, K plus 1 factorial K. K plus 1 factorial K will be K plus 1. Or we can do one thing. Okay, this one I hope you understand. This one I think you Understand this one and this one. K 6 factorial 5. 6 factorial 5. This one 6. Look here. 6, I have written here 6 equal to 6 into factorial 5. This one I think you understand. Factorial 6 equals to 6 into factorial 5 is greater than okay, k plus 1 2 to the power k. Okay, since look here, factorial k is greater than 2 to the power k. Factorial k into k plus 1 is greater than, so factorial k is greater than 2 to the power k. K plus 1 as it is. K plus 1 left hand side there is k plus 1, right hand side there is k plus 1. Left hand side there is factorial k, right hand side there is 2k. Left hand side there is factorial k, right hand side there is 2 to the power k. That is what I have written here. Now this one let us write again, k plus 1 2 to the power k. This one if we multiply 2 to the power k into k plus 2 to the power k. Okay. This one is also greater than 2 to the power k into 4. Okay. Is greater than 2 to the power k into 4 is greater than equal to 4, I think, in the question. Plus 2 to the power k. In place of k, I have written 4. N is greater than 4. That means least value is 4. The value of k will be least 4. So I have put 4 here. N is greater than 4 means k is greater than 4. So least value is 4. So we can put 5, 6, 7, 8, 9. But least smallest value is 4. So 2 into 2 to the power k into 4 plus 2 to the power k. Now we can write 2 to the power k. This one we can write again 2 to the power k into 2 square plus 2 to the power k equals to 2 to the power k plus 2 to the power k. 2 to the power k. Now we can take 2 to the power k common. Here only you can take common. 2 to the power k common. 2 square 4, 4 plus 1, 5. 2 to the power k into 5. 2 to the power k into 5. 2 to the power k into 5. Okay. Now let me wrap this one. I will show you one different. This will be difficult for all of us. So let us do another one, another process. Left hand side. So let us start the sum from this one. Let us start the sum from this one. Then this will be easy for us. Let us write, since factorial k is greater than 2 to the power k. Now factorial k we can write k plus 1 into factorial k plus 1 into 2 to the power. Both sides we have multiplied k plus 1 because there is k plus 1. So this one we can write factorial k plus 1 directly, because this one already I explained. K plus 1 into factorial k, bigger one will be factorial. Now this one you can write 2 to the power k into k plus 2 to the power k. So here k into 2 to the power k plus 2 to the power k. So factorial k plus 1 2 to the power k into k, 2 to the power k into k. Okay. So this one will be key. 10 is greater than 4 plus 2, or 10 is greater than 4. Same thing. 10 is greater than 4 plus 2, or 10 is greater than 4. Same thing. So next we can write factorial k plus 1 is greater than 2 to the power k, 2 to the power k into 2. K we can write 2 because k is greater than factorial n is factorial k is look here, 4 into 2 to the power k and 2 into 2 to the power k. Okay, so this is k. You can put k any number here. In previous sum we have put 1 somewhere. In place of k we have put 1. Here we can put 2, no problem for us. Any number we can put, as we have to get k plus 1, that is why we have written 2. Power is 1. So factorial k plus 1 is greater than 2 to the power k plus 1. Number 12. Number 12. Let Sn equals to 1 plus a whole to the power n greater than 1 plus n a, for 1 plus a greater than 0. It is given. Condition is given. So for n equals to 1, S1 is equal to LHS, LHS 1 plus a 1. So 1 plus a. RHS 1 plus 1 into a. So 1 plus a. So LHS is equal to RHS. Here LHS equal sign is there. So RHS, therefore if greater sign is there, also equal sign is there. So equal is proved. So Sn is true for n equals to 1. Greater than equal, so equal sign can be also proved. Now assume part we can write yourself, same meaning. Now to prove as k plus 1, 1 plus a whole to the power k plus 1 greater than equal to 1 plus k plus 1 into a is true for n equals to k plus 1. N equals to k plus 1. Now we will do the sum. Now we will actually, here what we have to write, 1 plus a k greater than equal to 1 plus ka. This is for sk. This is what we will start, since 1 plus a k greater than equal to 1 plus k a. This is what we will start from here. Then we will multiply both sides. 1 plus a. Why 1 plus a we will multiply? Because 1 plus a, because in left hand side 1 plus a to the power k plus a. Here 1 plus a power 1, 1 plus a k, that is why both side 1 plus a multiplied, so that we get 1 plus a power k plus 1. I hope you understand this. Right hand side you have to do the calculation. Here 1 plus k plus 1 into a. So we will see what we get actually here. Let us see, multiply 1 into 1 is 1, 1 into a is a, ka plus ka square. 1 plus a whole to the power k plus 1 greater than equal to 1 plus this one a, if we take common, what we get, k plus 1 a into k, a into 1 a plus k square. Now we can write directly 1 plus a whole to the power k plus 1 greater than equal to 1 plus k plus 1 a. This one can be neglected directly, hence proved. Why this one can be neglected directly? Look here. 10 is greater than 4 plus 2, or 10 is greater than 4, 2 can be neglected. 10 is greater than 4 plus 2, 10 is greater than 4, same. 10 is greater than or equal to whatever it is. 10 is greater than equal to 4 plus 2. So 10 is greater than equal to 4 written, same thing, because we need this one only. So till this much, exercise 3.1 is finished. There is some confusion in number 11. So this one I will explain in next video again. Number 11 I will explain again nicely, properly, so that all can understand. So till then, have a good day.